We close out our exploration of Chapter 12 with Section 12.6, Adding and Subtracting Rational Expressions. And just like when we add or subtract fractions, we need to focus on getting a common denominator. So if you have a rational expression added to another rational expression and they have a common denominator, then you simply add across the numerators and keep that common denominator. Likewise, if you're subtracting, then you subtract across the numerators and you keep that common denominator. And in addition to looking for a common denominator, we also want to look for some opportunities to cancel and simplify. So let's go ahead and look at some examples and see this at work. So here we have, find the sum, 2x plus 5 over 3 plus x minus 6 over 3. Well, we already have a common denominator of 3. And so we can go ahead and add this. We already know our denominator is 3, and we add across the numerator. So we have 2x plus 5 plus x minus 6. And then notice that in the numerator we can combine like terms. We have a 2x and x will combine to give us 3x, and then 5 minus 6 will give us negative 1. So we end up with 3x minus 1 in the numerator and then 3 in the denominator. And we cannot factor this 3x minus 1 any further, and so we're done. Notice that we can't just cancel 3's here because this 3 is part of a term that's involved with a subtraction. We need to have this involved with only multiplication in order to cancel. So we're done with that one. Number 2, again we have a common denominator already, 4x plus 8 and 4x plus 8. And if we want, we can just go ahead now and keep that common denominator of 4x plus 8 and then add across the numerator. So we have 6x plus 12. But now notice that we can do some factoring here, because we can factor a 6 out of the numerator to get 6 times x plus 2. And then we can factor out a 4 in the denominator to get 4 times x plus 2. And now we have an x plus 2 as a factor in the numerator and as a factor in the denominator. That means we can cancel that binomial x plus 2. Likewise, or in addition to that, we can simplify the 6 over 4. 2 will go into 6 3 times, 2 will go into 4 twice, and we end up with 3 halves. So our variable ended up getting eliminated. Okay, number 3. Here we do not have a common denominator yet. And so we need to find the least common multiple of these two expressions, g plus 3 and g minus 3. And one way to get that is to go ahead and multiply the two together. And in this case, that's definitely what we're going to need to do. So we have g plus 3 times g minus 3. There's our common denominator. The way we adjust this denominator to get this denominator is to multiply by g minus 3. That means we also need to multiply this 5 times g minus 3. And then we're going to add. And now in the second case, we need to multiply this denominator by g plus 3. So we need to also multiply our numerator, 6 times g plus 3. And now we can go ahead and apply the distributive property. So we have 5 times g minus 3 will give us 5g minus 15, and then plus 6g, and then 6 times 3 plus 18 over, and we still have g plus 3, g minus 3. Now we can combine, combine like terms. 5g plus 6g will give us 11g, and then negative 15 plus 18 will give us plus 3. So 11g plus 3 over g plus 3 times g minus 3. And we cannot factor this any further. There's no more simplifying that we can do, so we're done. In number 4, n plus 2 over 5 plus 3 over n plus 1. Again, we need a common denominator, and our least common multiple here is going to come from multiplying 5 times n minus 1. So in this case we need to multiply the first expression by n minus 1 in both the numerator and denominator. So we have n plus 2 times n minus 1, and then we need to multiply the second expression by 5 in both numerator and denominator. So we have plus 3 times 5. And then we can go ahead and multiply this out. If you want, you can set up your box. And we have n plus 2 times n minus 1. Or if you've gotten really accustomed to this by now, you can just look at it and say, oh, that's n squared, and we'll get plus n minus 2. And then we also have the plus 15 here. And we can keep this as 5 times n minus 1 in the denominator. And then the only thing we have left here now is to combine. We have a negative 2 plus 15. So we end up with n squared plus n plus 13 over 5 times n minus 1. And we should check now to see if this can be factored back into two binomials. And in this case it cannot be, and that means we're done. Okay, number 5. So similar idea, but now we're looking for a difference rather than a sum, and so we're simply subtracting rather than adding, but we still need a common denominator. And so to get a common denominator, first of all focus on the coefficient 5 and 6. The least common multiple of 5 and 6 is 30. So we're going to have to multiply this by 6, and then look at your variables. There's no j in this expression in the denominator, so we need to multiply by j. We have a k squared, which matches a k squared. So if we multiply times 6j, we'll end up with a 30jk squared here, and we're going to do the same thing over here. We already have a jk squared. All we need to do is multiply this 6 times 5 to get 30jk squared. So we also need to multiply the numerator times 5. So we end up with, we'll have 6j times 6j. I'll go ahead and write this out for now. 6j times 6j minus 4j times 5 all over 30jk squared. So this is going to equal 36j squared minus 20j over 30jk squared. And now we look at the numerator and we ask, is there anything that we can factor out here? And we can. So if you look at 36 and 20, the greatest common factor here is going to be 4. So we can factor out a 4. We can also factor out a j because both terms have a j. So we have 4j times 9j minus 5 over 30jk squared. Okay, so now in the denominator we have all factors here, and in the numerator now we have two factors, 4j times nj minus 5. So now that this j is a factor, we can go ahead and cancel the k that's in the the j that's in the numerator and the j that's in the denominator. We can also simplify the 4 over 30 because they're both divisible by 2. 2 will go into 4 twice, 2 will go into 30 15 times. And we end up with 2 times 9j minus 5 over 15k squared. And now we've simplified as far as we can, and that's our answer. Okay, number 6. Here we actually have a common denominator already, and so when we subtract, we can simply subtract across the numerator here so that we have t minus 4, and then our common denominator is already there, t squared minus 16. But now we need to realize that this is a difference of two perfect squares, which means we can factor it. This is equal to t minus 4 over t plus 4 times t minus 4. So we have a t minus 4 as a factor in the denominator. That means it can cancel the t minus 4 that's in the numerator. We still have then 1 left in the numerator, don't forget that, and then t plus 4 in the denominator. And there's our answer. All right, and finally, number 7, we have 9 over h plus 5 minus 7 over h minus 4. So here, we're going to need to multiply these two binomials together to get our common denominator. So we have h plus 5 times h minus 4, and in the numerators, so here we need to multiply this expression by h minus 4 in both numerator and denominator. So we have 9 times h minus 4, and then minus 7 times, and in this expression we need to multiply by h plus 5, and then go ahead and apply the distributive property. So we have 9h minus 36 minus 7h minus 35. Don't forget that negative there. So minus 35, and this is all over h plus 5 times h minus 4. And then we can combine like terms. So we have 9h minus 7h will give us 2h. And then we have a negative 36 minus 35 will give us minus 71 over, and we still have that common denominator of h plus 5 times h minus 4. Okay, and we cannot factor this any further, so there's no more canceling, and we're done. So there you go with adding and subtracting rational expressions. Good luck.